module on speed control and equivalent circuit of three-phase induction motor. Sound control. Next to continue. Pre-assessment.
कौन? बच्ची है।
By the end of this module, you will be able to explain different methods of speed control of induction motor and analyze equivalent circuit diagram of induction motor. Click Next to continue. In this section of the module, we will learn to control speed of induction motor through the following three methods. 1. Varying rotor resistance. 2. Varying supply voltage. And 3. Varying supply voltage and supply frequency. Click each to learn more. Click each to know more. This method is applicable for wound rotor induction motors only. The speed of the wound induction motor can be controlled by connecting an external resistance in the rotor circuit through slip rings. As shown in the graph, the speed at which max torque occurs changes. If rotor resistance is changed, the value of critical slip will also get changed. The amount of maximum torque will remain unchanged. High rotor resistance produces high starting torque. High rotor resistance produces high braking torque during braking. This method comes with few disadvantages as well, like large speed regulation and low efficiency because of power loss in resistances. Click Next to continue. Click each to know more. In this method, maximum torque changes. The speed at which maximum torque occurs is constant. At max torque, XR equals to RR upon S. It is relatively simple method as it uses power electronics circuit for voltage controller. It is suitable for fan type load. The only disadvantage is no large speed regulation is available since the rotor speed is same as the synchronous speed. Click Next to continue. Click each to know more. This is the best method since supply voltage and supply frequency is varied to keep voltage to frequency ratio V upon F constant. It maintains speed regulation. It uses power electronics circuit for frequency and voltage controller. It provides constant maximum torque. Click Next to continue. There are two ways of speed control for all the three methods, which is either constant torque or speed. The diagram shows the comparison. Click Next to continue. Click Next to continue. Let us now learn about the equivalent circuits of induction motor. Before that, give your attention to the following points. Never use three-phase equivalent circuit. Always use per-phase equivalent circuit. The equivalent circuit always bases on the star connection regardless of the actual connection of the motor. Induction machine equivalent circuit is very similar to the single-phase equivalent circuit of transformer. It is composed of stator circuit and rotor circuit. For better understanding, there are four following steps. 1. Rotor winding is open. 2. Rotor winding is shorted. 3. Keep the rotor current change same. 4. Revert to the stator side. Click each to know more. Now learn about the equivalent circuits of induction motor. Before that, give your attention to the following points. Never use three-phase equivalent circuit. Always use per-phase equivalent circuit. The equivalent circuit always bases on the star connection regardless of the actual connection of the motor. Induction machine equivalent circuit is very similar to the single-phase equivalent circuit of transformer. It is composed of stator circuit and rotor circuit. For better understanding, there are four following steps. 1. Rotor winding is open. 2. Rotor winding is shorted. 3. Keep the rotor current change same. 4. Revert to the stator side. Click each to know more. If the rotor is not rotating, following is the equivalent circuit. Here, the frequency of E2 is the same as that of E1, since the rotor is at standstill. At standstill, S equals to 1. To know the meaning of all abbreviations, click here. Click Next to continue. Under normal operating conditions, the rotor winding is shorted. The equivalent circuit is as follows. Here, the frequency of E2 is Fr equals to Sf because rotor is rotating. Click Next to continue. If the rotor current is kept same, following will be the circuit. Click Next to continue. When referred to stator side, following will be the equivalent circuit. On referring, the values will change as follows. Show the following equations. Here, X2 and R2 will be given or measured. In practice, we do not have to calculate them from above equations. Always refer the rotor side parameters to stator side. RC represents core loss, which is the core loss of stator side. Click Next to continue. Click Next to continue.
Post-assessment.
Thanks. You have completed the course.